Hi everyone, it's Mrs. Cox. I hope that you're having a fantastic day. I'm also accompanied by in my living room my dog Stark and my cat Magic, and we're going to do some awesome math with you guys right now. First off, let's all thank Mr. DeTamble for coming in and covering for me. He's just as awesome as I am. I'm sure he's going to do an awesome job. And just to help you guys out with some of the math, I'm going to make these videos. Hopefully they're kind of short and sweet. Feel free to play them back at home if you're confused. You guys can pause the lessons, rewind, and go back. Throughout the recording, you're going to hear my dog and my cat probably playing right on cue. I promise no animals were harmed in the making of this video, and when my cat makes that ridiculous meowing sound, she's actually playing along and is probably about to kick my dog's butt. So, let's talk about exponents. I thought that I could go back over Friday's lesson. We're going to nix those letters, so no more variables. We're just going to look at exponents in this lesson, and then tomorrow we'll bring the letters back into play. So on Friday, we learned 4 important rules, and I have 3 of them right here. So maybe if what we can do, we can take a second to pause the video. I want you guys to make this table in your notes. Remember, you still need a pen and a pencil. A pen or a pencil and a piece of paper. We're going to copy down this note. I'm going to make it a little bit more structured than Friday was. Okay, so pause the video, copy it down. All right, now that the table is copied down in your notes, let's do an example. So this law right here that I'm looking at, that first law right here, this is our product law. And in your table, you might want to write above it or beside it that this is our product law. In our product law, we learned that as long as our letters have the same base, we can add the exponents. Okay, so let's do a real world example. Let's get rid of these letters because we all hate letters apparently. So I'm going to do 3 to the power of 3 times 3 to the power of 4. The first thing I notice is that my bases are both 3. And just remember, if you're like Miss Cox, what the heck is a base? That in my exponent, I have a couple of things that we should know. The first one is that if the A is my big number, then I'm also going to call this, my base. Okay? If the B is my little number, I'm going to call this my exponent. Altogether, these things make what we call a power. Okay? So let's just go back over that quickly. The A, or my big number, like in my example, the big 3, that's in both of them, that's my base. The B, or like in my example, the little 3 and the little 4, those are my exponents. Everything all together, that makes my power. Great. Okay, so I just said that I can add these whenever I have my exponents. Whenever I'm multiplying 2 together that have the same base, I'm going to add the exponent. So now I'm going to write my base again. I'm going to do 3 plus 4 here. Okay. And what is 3 plus 4? That is right. I'm going to zoom in a little bit so I have more writing room. 3 plus 4 is going to be 7. Okay, so I rewrite my base, and this is the same thing as saying I have 3 to the power of 7, or 3 to the exponent 7. All right, let's see a proof here. In my proof, I'm going to expand out all of my exponents, and remember that we said that our exponents are the same thing as saying that it's that number, that base, multiplied by itself 3 times, okay? So 3 to the power of 3, that's the same thing as saying 3 times 3 times 3. And then we also said that I was multiplying it by 3 to the power, 3 to the power of 4, which is 3 times 3 times 3 times 3. Okay, here's where my proof is, or the example of how this works, okay? I'm going to count up how many 3s I have. I have 1, 2, 3, 4, 5, 6, 7. That's why we're able to say that with this product rule, I actually have 3 to the power of 7. All right. Let's look back here. That's my product rule. The next rule that we learned about was my quotient rule. And if you remember, quotient is just a fancy word for dividing. And my proof for this example, I'm going to do 3 to the power of 6 over 3 to the power of 2. That is a really messy 6. I'm going to erase that. Okay. It's a little 6. It's an exponent. And we said that in my quotient rule, I'm going to subtract my exponents. Okay. I'm going to do the same thing here. I'm going to rewrite my base. And now I'm going to do 6 minus 2. 6 minus 2 is 4. Okay, so let's again look at the example of this. If I have 3 to the power of 3, if I have 3 to the power of 6, math teacher's going crazy, over 3 to the power of 2. That's the same thing as me saying I have 3 times 3 times 3 times 3 times 3 times 3, all divided by 3 times 3. Okay? You might remember from last year or the year before that if I have the exact same number on top as I do on the bottom of a fraction, I can just cancel it out. So this 3 and this 3 are going to cancel, and this 3 and this 3 are going to cancel. Now I'm going to count up how many 3's I have left. 1, 2, 3, 4. That's how I can say that this is 3 to the power of 4. Okay? Last example. This was our power to a power rule. And in this rule, I'm going to have something inside of my bracket and then another exponent outside of my bracket. And when that happens, I'm going to multiply my exponents together. So let's look at this. I have 3 to the power of 2, let's say, all to the exponent 3 on the outside. I'm going to rewrite my base, which is that big 3. And now I'm going to do 2 times 3. 2 times 3 gives me 6. So let's look at this proof. If I had 3 to the power of 2 to the power of 3, what that really means is that I have 3 to the power of 2, 3 to the power of 2, 3 to the power of 2. I have that bracket 3 times. Well, we said that anything squared is really itself multiplied twice. All right, now let's count up our 3's. Again, because this is squared, that's really the same thing as saying 3 times 3. So I have 1, 2, 3, 4, 5, 6. That's how I'm able to say 3 to the power of 6. Okay? Okay. Let us try some examples. Okay, so again, pause the video, write down the examples. When you're done, press play again. All right, I'm assuming that you've written down the examples. Let's go through them. I want you to expand these first. Okay, we are expanding them, then simplifying them. That means that we're going to write out how many 9's we have altogether. 9 to the power of 4 means I'm going to have 4 9's. 9 to the power of 3 means now I'm going to have 3 9's. If I count them all up, I'm going to have 1, 2, 3, 4, 5, 6, 7. Now I have 9 to the power of 7. Okay? Might hear my dog inching a little closer. He can sense the distress in the classroom and he's coming to give some emotional support. All right, let's try this again. Now I have 9 to the power of 5 times 9 to the power of 2. I'm going to write 9 times 9 times 9 times, and then I have my 2 9's from my power of 2. I'm going to again count up how many 9's I have. I have 1, 2, 3, 4, 5, 6, 7. So now I can write this as not 97. Don't ever write it as 97. 9 to the power of 7. Okay. All right. You will notice that we are changing courses a little bit. Now I have 4 to the power of 5 divided by 4 to the power of 3. So let's write out how many 4s I have on top of my fraction. 4 to the power of 5 means I have 4 times itself 5 times. Okay? Now let's do the bottom. 4 to the power of 3 means I have 4 times itself 3 times. We just said up top that if there's a number on the top that's the same as the bottom, I can cancel those out. This 4 is going to get crossed off. These 2 are going to get crossed off. These 2 are going to get crossed off. Now, I can write it as a single power. I only have 2 4s left. So I have 4 to the power of 2. Okay? Okay, last 2. We're going to look at our power to a power rules. So, in my bracket, and I'm going to keep my brackets just so you guys can see it, I have 2 times 2 times 2 times 2. Now, this 3 on the outside means that I'm going to have that bracket 3 times. Okay? All right, I know I'm into the next example. That's okay. Now we're going to count how many 2's I have altogether. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 2 to the power of 12. Final example for this mess. I'm going to do the same thing. 7 to the power of 2 means that I'm going to multiply 7 by itself twice. But on the outside, it says that I have 4 of those brackets. So I'm going to have 7 times 7, 7 times 7, 7 times 7. Okay, now I'm going to count up all my 7s. I have 1, 2, 3, 4, 5, 6, 7, 8. So I could say that this is the same thing as saying 7 to the power of 8. Okay? All right, last example, and then you guys are going to have lots of time to work on some of these questions yourself, okay? Instead of expanding it out, because that takes a long time, I want you guys now to just write these as a single power, and then we're going to evaluate. Whenever we see this word evaluate in math, that means that we're going to get bigger numbers. Basically, you are actually using a calculator here, okay? I'm going to actually use a calculator here. Okay. If I'm looking at 2 to the power of 3 times 2 to the power of 5, I notice that I'm multiplying, which means I'm going to use my product rule. In product rule, it means that I'm going to take my base. I'm going to add my exponents. So this is an exponent, my 3. And my 5 is also an exponent. So I'm going to do 3 plus 5. 3 plus 5 is 8. In your calculators, I want you guys to do this. When you are done, I want you to write the answer below. And you should get the answer of 256. Okay, that's a 5. 256. Okay, let's look at this one. This one has negatives in it. Negatives are real, okay? You're still going to rewrite your base. This is still my product rule, so I'm still going to take my exponents and I'm going to end up adding them. Okay, so now I'm going to do 2 plus 4. This is going to give me negative 3. 2 plus 4 is 6, so negative 3 to the power of 6. You're going to do the exact same thing in your calculator. You just need to make sure that you actually press the negative sign. If you are using calculators, scientific calculators, it's always best when you're dealing with negatives to put in the bracket. So I want you to do bracket, negative 3, close the bracket, to the power of 6. You know you did this right if you get a positive number. In fact, you should get 729. You did not do this right if you got negative 729. You need to master that bracket tool. All right, last one. 8 to the power of 15 over 8 to the 13. Okay, I'm going to look at this. I see that I'm dividing, so this is my quotient rule. That means I'm going to subtract my exponents. So I'm going to do 15 minus 13 here. 15 minus 13 gives me 2. 8 to the power of 2 is 64. Okay? All right. So for today, right now, what you're going to do, you are going to read the examples on page 112 to 113, and then you're going to copy down that key concepts box in your note. Once you're done that, you have 2 tasks. Your first task is to do questions 1 to 9 on page 114 to 115. Your second task, and Mr. DeTamble, I'm sorry I didn't write this in the notes, is to finish questions number 1 to 7 from Friday's homework. Just 1 to 7. All of those other ones that happened in after 7 when they had those letters in them, that is tomorrow's lesson. Okay? Again, I hope that you guys are being awesome. Don't forget about the incentives for being good kids. Okay? And I will see you guys soon.